Good afternoon, everyone. My name is Munashe Mukweya. I'm a junior computer science and cybersecurity major from Grambling State University, and my project is Onus. I'm the sole founder, and so let's begin. Greenhouse gas reporting landscape has been since 2009. Industries have had to basically report all their emissions under the greenhouse gas reporting program, and under that program, 8,200 facilities and suppliers have to submit that data to EPA's electronic greenhouse gas reporting tool. So sites with continuous emission monitoring systems have to assemble vast amounts of data, have to basically compare this data to their previous data, show what's changed, show what's still the same, and also basically go according to the guidelines that have been set by the EPA in their CFR Part 90 regulations. So as you can see, 8,200 facilities have to report, and according to EPA's own analysis, this annual reporting costs about $303 million annually. So any basically tool that will allow these industries to basically automate the system could potentially save millions. Right? So, yes, here we have some quotes from actual designated representatives of some of these industries. As you can see, they also have trouble keeping up with all this data that coming from these continuous emissions monitoring systems. So one of the challenges, we have manual and fragmented data that lives inside the system. Basically, it's all separate, it's all over the place, and there are few people who have to keep up with this data from basically many facilities. You know, one company could have many facilities all over America, all over Louisiana, and you know, because this is such a human process, it's error prone. There's so many calculations, so many equations to memorize, and it's also resource heavy because you have to coordinate hundreds of people, hundreds of facilities, and of course, hundreds of monitoring systems. Here we have another quote. Again, an expert actually complaining about the manual work that goes into this reporting and how stressful it can be. So those are the key pain points. Compliance risk, because it's such a manual and error-prone task, it can have repercussions because any errors, any compliance errors, the company can face fines, can face audits from EPA themselves. So it is important that there are no errors in the process. As I mentioned before, it costs millions every time there's delays in reporting, every time there's basically any errors that have to be, that require resubmission. And basically it wastes time for experts who want to work on other things, such as finding ways to reduce these emissions. So what's my solution? My solution is an agentic continuous emission monitoring system to electronic greenhouse gas reporting to reporting workflow. Right. So what does this mean? It means basically users, designated representatives for these facilities, they upload their continuous emissions monitoring system data to our system. Onus has an agentic AI that basically validates this and verifies this data against the given regulations. Right. So we have the SEPCAM's data, agentic AI processing. So what I did, I implemented a vector database in which I fed basically all relevant subpart data. So basically all the relevant EPA regulations. This would allow the agentic AI to basically call searches, semantic searches on this vector database, and it can basically compare the given data from the designated representative with the regulations to validate and verify whether this data is correct, whether this data is ready to be submitted to EPA. Right? With that, it generates reports. So EPA takes 14 forms or XAML schemas to report your data emissions. So at the end of the workflow, the agentic AI produces these reports, which the user can then take to the electronic various class reporting tool and submit the emissions for the year. Right. And this is basically the system. So we have data ingestion, we have Onus, imports emissions and estimated data from spreadsheets, sensors, or databases. The AI agent infers applicable EPA rules, units, and emission factors based on the facility type and reporting subpart. Right. Then we have computation and QA/QC. So the agentic AI also has tooling capability, which allows it to call equations. So basically, if a facility is on the subpart C of EPA regulations, the agentic AI can call those relevant equations and run them on the data, and we can get value computations without errors, without any validation mistakes. It then generates the forms, which will then be able, which you can then submit to the ATGRT platform and submit the emissions reporting for the sub-reporting year. Also as an audit trail, because AI can basically take basically in non-discrete data that it can then report semantically. So this is the current UI. Here, the user can select facility, upload a spreadsheet of all the reporting data, select the 14-year, and upload. So the process takes time because at the end of the day, it's AI generating all of this. So let's just get that. And at the end of that, it basically fills out this form. This is from the ETGRT template for CEMS reporting for subpart C. These are the core features. They can be connected live to CEMS data, fuel logs, operational parameters, automatically aggregate emissions with future API logs. Basically meaning through Internet of Things, we can connect to these CEMS systems and basically get live data, right? So there's automated form generation, validation, and submission. Basically, that means the user has to validate that the form has been filled out correctly and is verifiable. So the benefits. This will save plenty of time. These sources claim that an automated emission reporting system would make the reporting routine 30 to 70% faster. It cuts manual effort by around 40%, with 7% of emission data management handled by software. It eliminates errors. Users can submit their data with confidence that it has no errors, it has no mistakes. And there's a huge market opportunity because of the rising carbon market. So there's also employee benefits. It reduces farm work, manual labor, and basically improves productivity. And this is just the future roadmap, what we plan on doing for the next iteration. So we have mandatory compliance. So right now, this is the way we are at. We have mandatory compliance with the EPA regulations. Also plan on doing voluntary compliance for carbon markets, as well as live data integration with Internet of Things devices.
You can wrap it up.
Thank you.